Welcome to the new video. In this video, we will be learning and understanding AWS Lambda. We will be learning the key features of AWS Lambda, the working of the Lambda code, and the real life use cases where we really use AWS Lambda and perform our use cases depending on the requirement. Let's get started with the video. Key features of AWS Lambda. AWS Lambda is a serverless architecture, which means we will be only focusing on development of the application or the microservice. We are not bothered about the compute capacity, that is the servers and the networking part, which makes our microservice or the application to go real time in a quicker fashion. Auto scaling. Auto scaling is a feature of AWS Lambda which allows the compute capacity to increase or decrease depending upon the demand. Sub-second metering. Lambda costs based on 100 milliseconds of compute time. So every 100 milliseconds you will be using the compute power of AWS Lambda, you will be costing accordingly. Consistent performance. Making AWS Lambda a serverless architecture, there are no flaws in networking part or the insufficiency of the compute power, which makes the performance of Lambda consistent over the longer periods and cost effective. Since we are focusing mostly on the development of the application or the microservice, the Lambda development or the application development becomes cost effective. Working of the Lambda function. Now we have created a code which performs certain action. Now we have the code. How are we going to run this code? So if we see the image, we have a triggering mechanism which runs the code and the output of the code is stored in some destination. So there is an event which will trigger our Lambda function, that is the Lambda code. The code will be executed and the output of the code is sent to some other destination. The events which can trigger a Lambda function can be something like putting an object into an S3 bucket or SNS topic or a simple message coming from an SQS queue. Any of these, or there are many events which can be used to trigger the Lambda code and execute the code. As the application becomes bigger and bigger, we will be executing more and more Lambda functions on the same kind of architecture. So you will be importing the modules in every Lambda function. In order to avoid this, there is a concept called Lambda Layers. Let us understand Lambda Layers. Now, according to the picture, there are four different modules that are being used in three different Lambda functions. So if we import the four modules in all the three functions, the code becomes heavy to execute and your compute performance will be compromised. So Lambda layer is a layer wherein you import all these modules in the layer and you can use that layer on top of your Lambda function, and you can use this layer on multiple Lambda codes, which makes your Lambda codes lighter and faster to execute. And for a single Lambda function, you can use up to 5 Lambda layers, which makes your compute faster and your Lambda function performance will be enhanced over multiple times. Different Lambda function components. So destinations. Destination is other AWS services or any other service which takes the output of the Lambda function and uses as an input. Lambda trigger. Trigger is an event which is used to trigger our Lambda code. And layers. As we have discussed, Lambda layers are on top of Lambda code, which makes our compute faster and makes our code lighter. And function URL. And to check the Lambda's status every time, you no need to go to your AWS management console. You can assign a function URL which you can use it to track your Lambda function. You just paste it in your Chrome browser, anything you use, and your function status will be shown on the URL, which makes the Lambda more versatile to use across board. And test event. Before we deploy our Lambda function to real time or production, we want to test it using different events or different workloads or payloads. You can configure a test event such that resembles the real time payload, and you can execute your code in order to understand the flaws in your code, or you can debug your code using the test event. These are the different Lambda function components. Now, let us learn about different attributes other than the components. These are the few other attributes of AWS Lambda. Concurrency. For example, your Lambda function is already executing and another event have triggered your Lambda function, and second time the Lambda function has been triggered. So you can parallelly run multiple times a single Lambda function. I mean, all the runs can be happening concurrently, which makes Lambda function more versatile. And 15 minutes runtime. So the constraint of Lambda function is it can only execute the code for 15 minutes. For runtimes greater than 15 minutes, Lambda function is not compatible for that. So other than using your Lambda function by deploying your code in the form of zip files, or you can script your code in Lambda code editor, you can use an container image to develop a Lambda function. And for example, now your Lambda function is developed by multiple developers, and you have a code signing configuration, which means every time there needs to be a deployment, it has to go through a code signing configuration, which makes your Lambda more authentic and failure proof. Let's get into the Lambda code anatomy. Every Lambda code has three kinds of features in it: Lambda handler, an event, and the context. So, Lambda handler is a function inside which you will have the processes you want to execute. And event is the payload that you get from a trigger. It is in the form of a JSON basically. And context is a input which stores the execution variables, like what is the runtime you're executing, what is the compute you're using, what are the different function elements that are integrated when you create a Lambda function. So Lambda code anatomy comprises of Lambda handler, Lambda event, and the context. So once you are executing number of lambdas, you want to understand the metrics to improvise to make the performance enhanced. So Lambda offers you different kind of metrics, out of which the first one is performance metrics. How much of memory you are using, how much of compute capacity is you are using, what is the time you are using to execute a Lambda function, using which you can optimize your Lambda. And concurrency metrics, how many concurrent invocations are happening, how many times the Lambda is being invoked simultaneously is shown in the concurrency metrics. The final metrics are invocation metrics. How many invocations of your Lambda happened in a day, or how many times your Lambda function is invoked, and which invocation is causing more compute capacity, or shown in invocation metrics. So Lambda gives you performance metrics, concurrency metrics, and invocation metrics. So, what are the use cases where we can use AWS Lambda to leverage and execute the microservices or the applications? So, the first use case is data processing. Let's say a file is being coming into your S3 bucket every day, and you want to make it into a different format so that it can be used into some other ways. So, you can set up an event to your S3 bucket such that every time a new file comes into your S3 bucket, it will act as an event to your Lambda, and it is triggered, which runs the code and changes the format of the file depending upon the processing you want, and it is fed into different AWS service or into a different purpose. Instead of S3 bucket, here you can have an SNS topic as an event or an SQS queue. This comprises into data processing use case where you can process the data depending upon the event, like putting an object into an S3 bucket, receiving a message into an SQS queue or an SNS topic. So the next use case we are discussing is job scheduling. For example, you are having a requirement of running a particular code depending on the time of the event or execution time or an code CloudWatch event. You can set up CloudWatch event as a trigger to your AWS Lambda and execute your Lambda function. Like for example, every day at 9 a.m. you need to send some notification scripting some message in it. So you can set up a CloudWatch event that triggers your Lambda at every day 9 p.m. So you will be sending the message at 9 p.m. every day based on the event triggered from CloudWatch and AWS Lambda as a function. The final use case that we are discussing are serverless API backend. So you can set up many APIs in a serverless API backend microservice in which you use API gateways output as an input to your AWS Lambda, and your Lambda function writes into your Amazon DynamoDB. That's the table where you store the output of the Lambda. So API gateway can be used to trigger multiple HTTP requests. Depending on the request, you will execute the Lambda function. For example, you have set up a Lambda function for a post command. You have set up a Lambda function for a get command or a put command. So according to the request, the Lambda is processed and the output is stored in the DynamoDB. So these are the different Lambda use cases. With this, we have come to the end of the video.